In the previous lecture, we saw the classification for numbers, and there we saw different types of numbers available, and out of all the classifications we had, we saw one type known as whole numbers. So what are whole numbers? Whole numbers are the numbers including positive integers or natural numbers along with 0. So 0, 1, 2, 3, 4, 5, 6 and so on are known as whole numbers. And in this presentation, we are going to talk about two types of whole numbers: prime numbers and composite numbers. Prime numbers are the whole numbers that cannot be obtained by multiplying other whole numbers. Pretty simple to understand. For example, if we have number 3, then we cannot have number 3 by multiplying other two whole numbers. And if I take number 6, then 6 is a whole number which we can have after multiplying 2 and 3, the other two whole numbers. So in this case, 6 is a whole number which we can have after multiplying other two whole numbers, and therefore 6 is not a prime number, but it is a composite number. So if we can obtain the number by multiplying other whole numbers, the number is called as composite number. So I hope you now understand what are prime numbers and what are composite numbers and the difference between them. Now, if we talk about this prime number 3, then we can have it by multiplying 1 and 3. This means 3 is perfectly divisible by 1 and itself. So all the prime numbers, they are perfectly divisible by 1 and itself. So we have two divisors for prime numbers, and the two divisors, they are positive. So I hope this important point is now clear. Let's move on to few other important points, out of which the first one is neither prime nor composite. This is one important point to understand. One is neither prime and it is nor composite. It is not prime because I just said that prime numbers have two positive divisors, but one, it has only one single divisor, that is itself, and therefore 1 is not a prime number. Now what about composite part? 1 is not composite because we cannot have 1 after multiplying two other whole numbers. We can have 1 by multiplying 1 with itself. So 1 is neither prime and nor composite. Point number 2 is 2 is the only even prime number. So out of all prime numbers, 2 is the only even prime number. Rest all prime numbers are odd in nature. Moving on to the third point, there are 25 prime numbers under 100. This is important because up to 100 prime numbers, they are asked in examination. So you should have this table in your mind. All the prime numbers, they are highlighted by green color in this table. We have 25 of them, and when you observe, you will find only 2 is even and all the other prime numbers, they are odd. So we are done understanding prime and composite numbers. Now we will move on to one example problem. In this example problem, we need to find factors of 15, and this particular type is our type 1 of questions we have in the chapter number systems. In this type, we need to find out different types of factors we have in a whole number. We will see some shortcuts in the next lecture. For now, we will try to find out the factors of 15 using the conventional method. We will have 15 like this, and then we will try to find out the perfect divisor of 15, which is also the smallest and except 1. And we know 15 is perfectly divisible by 3, giving us 5. Again, we will focus on 5 and try to find out the perfect divisor, which is not 1 and smallest, and there is none but 5 itself. 5, when you divide by 5, you will have 1. So in this way, we have the factors of 15. The factors of 15 are 1, 3, 5 and 15 itself. So the factors of 15, they are 1, 3, 5 and 15. So if I ask you the total number of factors, the answer will be 4. And what about the total number of prime factors? You can see we have 2 prime numbers, 3 and 5. So we have 2 prime factors. And what about odd factors? There are 4 odd factors. All the factors are odd, 1, 3, 5 and 15. This means even factors, they are equal to 0. So these are the factors question might ask you to find out. In this case, the number is 15, a small number, so it was easy to find out using the conventional method. But when the number is larger, for example 7200, then in that scenario we need to use the shortcut method, which we will understand in the next lecture. So this is all for this lecture. I will end it here. See you in the next one.